California WaterFix would modernize the State Water Project delivery system in the Sacramento-San Joaquin Delta in order to improve ecological conditions in the Delta and stabilize water supplies for much of the state. This program represents the first major modernization effort of the water conveyance system in more than 50 years. The following construction animation is based on the conceptual engineering completed to date for the Environmental Impact Report and Environmental Impact Statement. Future engineering phases would further refine the design. Construction would not begin until permits are obtained and activities coordinated with federal, state, and local agencies. This animation focuses on constructing shafts and driving the tunnels. We illustrate the plans for Bolden Island to represent the typical work proposed for launch shafts. Once the power, roads, and work pads are established, the tunnel contract for Bolden Island would be awarded, and the contractor would commence work on the actual tunnel-related activities. The contractor's first task would be to sink the two main launching shafts, one for each tunnel drive. Anticipated construction methods for this work would be with diaphragm cutoff walls. The walls are constructed by excavating material in a sequential manner, filling the excavated area with reinforcing steel, and then pumping concrete into the space. The walls are created in a sequential manner. Overall, this method allows the contractor to construct the shaft without impacting surrounding subsurface water levels. Once the cutoff walls are installed, the earth within the cutoff walls would be excavated, and a large concrete plug would be placed at the bottom of the shaft and tied into the cutoff walls. With the plug in place and the shaft sealed, the shaft can be dewatered. Next, the contractor would begin preparing the shaft to receive the tunnel boring machine, or TBM. While the shaft is being constructed, the TBM would arrive at the site. In some cases, a barge would be utilized to deliver the machine to the site. Once the shaft is constructed, the contractor would begin lowering the various pieces of the machine into the shaft for assembly. Tunnel mining would commence once the first few pieces of key machine equipment were lowered into the shaft. Fully assembled, the machine is approximately 400 feet long. As the partially assembled machine mines forward, subsequent pieces of overall machine would be lowered into the shaft and attached to the main apparatus. As the TBM mines forward, excavated earth would be removed from the tunnel. This material is referred to as reusable tunnel material, or RTM, since preliminary studies indicate that it may be possible to use this material for a variety of future applications in the Delta, including habitat restoration and strengthening levees. The RTM would come out of the ground with a wet and pasty texture. It would be carried via a conveyor belt to a handling and processing location. At this location, the RTM would be processed into a drier form and stacked in layers for stockpiling. Any water or residues collected from the RTM during the drying process would be sufficiently treated prior to land or water discharge. Under current program plans, the RTM would be stockpiled near the tunnel shaft sites. As RTM is being removed from the tunnel, concrete segmental liner pieces would be lowered into the tunnel and transported to the front of the TBM. At this location, the TBM would erect the individual segments into a completed ring, which would serve as the permanent tunnel lining that would structure all support of the tunnel and keep water from seeping into or out of the tunnel. This concludes the explanation of tunnel shaft construction and modern tunnel construction technology for the California WaterFix. For more information, visit the website www.californiawaterfix.com.